So here we go. So let's do it this way. We're still on the antiderivative. Now we've got to understand that the antiderivative is nothing more than the indefinite integral. And so instead of talking, beating about the bush, we can just express everything in terms of the integral. And so I'm just going to do it. Let's go indefinite. Integral. All right, so if we do a recall, basically we said that if, let's say, f is some differentiable function, it's a differentiable function, and big F is its antiderivative, then we can write the whole thing as in this form. All right. So this is where I believe we were looking at the last time. But that is what we call the indefinite integral. I think in the last video we talked about every item there. This symbol here is an elongated S that tells us that that is the integral. The f of x there is the integrand. The dx there tells you the variable of integration. Cap f of x is basically antiderivative, and because excuse me, because the antiderivative, they belong to a family of functions that differ by a particular constant. We always need to add a constant, in which in this case is c. This is an arbitrary constant. We don't know yet what this c value is. We will talk about what we call the initial value problems, and that will help us to determine what the c is. But until then, we just have to attach plus c. You can do plus k, whatever you want to do. But this is the idea about what we call the indefinite integral. I just want to quickly talk about rules, the indefinite rules, or integral rules, if you will. Integral rules. I believe that if you look at the first video, there's certain things that we talked about there, which they are coming from the rules, but we just want to delve deeper into what the rules are all about. And so the first one is the constant rule, or the constant multiple. The constant multiple rule. Let's say that if C is some real number, and f of x is some function, if you will, then anytime you have the integral of c of f of x dx, you can always push the constant outside your integral. So this is the same as I write c outside integral of f of x dx. So this is always true. This is the first rule that we have to look at Example would be if you have, let's say, integral of 3x squared dx, you can always rewrite this as 3 outside integral of x squared dx. I'm just going to leave it as s for now, but by way of the rule, this is how you can also express it. Are we good?
Yes.
All right. Let's look at the power rule. I believe we touched on that last time in the video. Let's look at the power rule. Over here, I'm just going to make reference to, the derivative. So remember that if I gave you d dx of, let's say, xn, if I'm taking the derivative of x to the power n, we understand that anytime we have a case like that, the power, becomes the coefficient, or better still, the power multiplies the base, and then we subtract 1 from the power. So that will look like this. That is when we take the derivative, okay? Now, what it is that this expression here becomes my function, my initial function, and whose antiderivative is going to be what? X to the n. So in other words, what this means is that then f of x equal nx n minus 1 has f, big F, equal that as its antiderivative. I believe now we get the idea, okay? And to avoid all these words, we can just put it in one integral, rewrite it as this. Dx is equal to xn plus c. Does it make sense?
Yes.
All right. So I'm just going to do a trick here. Look at it carefully. Now, you see, this n there is nothing more than a power. And normally, based on what we're doing here, n is just a value. So let me just put it here. I'm assuming that n is some real number, right? If it is some real number, then it is just, a constant, if you will. And so what I'm going to do is I'm just going to add 1 to any n, anywhere I see n, right? So add 1 to n, okay? So anywhere else that you see n, I'm just going to add 1 to it. Just bear with me here. So you have to have a case like this, n plus 1, n plus 1 minus 1, right? Because I'm just adding 1 to anywhere else that I see 1. Is that okay? Dx. Does it make sense?
Yes.
Yeah.
Okay. So I'm just going to simplify here. This is n plus 1 still. But if I simplify this one here, if I take out the parenthesis, the ones are going to cross out. So I'm just going to be left with xn dx equal that plus c. Well, if you want, I can, let me just do c1 here, just so that I would just want to make sure that this constants are, because we're going to be dividing stuff. Okay, so what I'm going to do now is, once I understand that n is a value, is some arbitrary constant, if I add 1 to it, it's still going to be some constant. And based on the first rule, I can push n plus 1 out outside of what integral, because it remains what, a constant. So I can do n plus 1 outside. And then I'm going to have something like that. And please pardon my handwriting. If you can see it well, let me know. Now from here, I can isolate the integral of x to the n dx, okay? And if that is going to be the case, I have to divide each side of the equation by what, n plus 1. So that means that I'm going to have are we good?
Yes.
Now, if you look at this carefully, the C1 is itself a constant. And if it is divided by n plus 1, which is also a constant, then the whole thing is going to be some constant that we don't know. So in that case, I'm going to use a C, a big C for all of that. Okay, so I can now do, whoa, n plus 1, n plus 1. And then I'll just do this one as a big constant. This is what we call the power rule of the integral. So please take note of that. Maybe you've already seen this, but that is the integral, the power rule for integral. In other words, if any function, if the integrand, if you will, has some kind of what, exponents, all that you do is you add 1 to the exponent and then divide by the resulting exponent. That will be it. Okay. And so this is a little bit different from the derivative. You understand that with the derivative, the power becomes the coefficient, and then we subtract 1 from the power. But because we're talking about antiderivative, there's what, a reverse of the process. And of course, if you pick this, if you pick x raised to n plus 1 divided by n plus 1, and you try to take the derivative of this, you should definitely get this. Or better still, if you're taking the derivative of your right-hand side, you should definitely get what this expression is. You can try it yourself, but that is always true, okay? So that is the power rule. Example will be, let me use block here. Example will be, let's say, solve something like 3x squared dx, right? Something like that. All that you're going to do is you now understand 2 rules. This here, you can apply the first rule with it, where the coefficient there can come outside of your integral. So that first off will look like this. And then based on the power rule, which we have just considered, all that you got to do here, the 3 stays, the 3 multiplies, and then you add 1 to the power. That is when you are integrating, divided by the result of your power, which is 2 plus 1. And then you add some constant, because that is the antiderivative. And when you do that, you're going to have 3 x to the third over 3 plus your c, and then you can simplify. Once you simplify, this is going to give you the 3's cross out, so x cubed plus c will give you your answer. So basically, the integral of 3x squared dx will give you that. Any questions?
No, I think we're good.
All right. Let's look at another rule. Let's look at the exponential. Now, the first one I'm going to consider here is e to the x, e to the x. Now, you understand that if I gave you d dx of e to the x, what is that? What is the derivative of e to the x?
E to the x.
It's the same thing, right? So what it means is that e to the x, the antiderivative of e to the x is itself. Is itself, okay? So basically, in terms of the integral, I can rewrite this as integral of e to the x dx is the same as e to the x, but remember that you need to attach a c, okay? Okay, so if you want, you can say it itself plus, let me put it this way, plus some constant, so that at least it doesn't become a misleading statement here. Is that okay?
Yes.
So if this is true, what if, I think I've exhausted the page. But let me go to the next page and then we can make a deduction from there. Are we good?
Yes.
Okay. So if that is true, what if I gave you d dx of e3x? What would be the derivative? Hello?
Would it still be E3x?
Yeah, but with something else too.
Plus c.
No, this we're just doing the derivative. We haven't come to the
Oh, right, sorry.
derivative yet.
Oh, right, it would then be times 3, right?
Times 3. So this is 3 e3x. Okay. I know you know this, it's just been a while, but that is going to be your answer. Okay. So what it means is that this expression here, if we call it a function, has this as its what? Antiderivative. So I can rewrite this as so this is where we will attach our c, but I'm going to do a c1, okay? And the reason is because I can pull this 3 outside the integral and then isolate my integral of 3 to the, e to the 3x dx, and then I'll get both sides divided by 3, okay? So I can rewrite this as this, which you can always do that by way of the first rule. And then I can divide both sides by 3 just so that I want to isolate this one here. So if I divide both sides by 3, I'm going to get something like this. Are we good? And this whole thing here will be a particular constant. So I'm going to use big C here for it. So this is always true. So look at look at it carefully. Look at it carefully. So long as there's a particular value here, the whole thing remains the same, but we get to divide. We get to divide by whatever that value here is. So I can do a general, in general. If let's say if K is any real number, then look at it carefully. If I have the integral of e kx dx, this is the same as I write e kx over k plus some c. This is always true. Is that okay?
Yes.
Yep.
So it doesn't matter what you are given, you should be able to do this easily. If you are given integral of e, let's say 5x dx, you just have to understand that this is just going to give you e 5x over 5 plus your c. That's it. Okay. Let's do the next one. I'm going to do the natural log. Okay. The natural log. We're still under the exponential. So again, I want to take it from the derivative standpoint. d dx, remember d ds of natural log of x, what is that?
1 over x.
1 over x. So look at it carefully, right? When you take the derivative of a natural log of x is 1 over x. In other words, the antiderivative of 1 over x will give us the natural log of x. But note that the natural log of x is always positive. Okay, so natural log is always positive. And so in this particular case, when you're doing the integral, you have to use an absolute on the x all the time. So basically, this is going to be written like this. If I have integral of 1 over x dx, this should be equal to natural log of x, but always absolute. And the absolute is because we want to get rid of any negative value, okay? Because the natural log should always be positive. And that is the main reason why we write it like this, okay? So take note of it carefully here, that anytime you have a case like this is always going to give you that, okay? Are we good?
Yes.
So, for example, if I ask you to solve this very simple one, let's say just 5 over x dx, you should be able to do this easily. Dx. Here I can pull the 5 outside by way of the first rule, and that will become something like this. Does it make sense?
Yes.
Yep.
Okay, so now by way of just this and what we've considered, we understand that this is just going to be natural log of x. So that will be 5 natural log of, but make sure that you put it in absolute form, and then plus what? Your c. That's it. Are we good?
Yes.
Let me do another one. Let's say the c. Remember this exponential one with any base. Let's say if I have, let's say f of x equal a to the x. Remember this one here. A case like this, right? If I ask you to find the ddx of a to the x, pardon me, a to the x, what is the derivative?
A to the x times the natural log of a.
A to the x times the natural log of a. Okay, so that will look like this. Okay, and so what it means is that the integral of that should give me this, basically, by way of the integral. So if I write it this way, it's going to be like this. Dx should be equal to that plus, let's say, some c1. But remember that the a there is a value. So a is any real number. Normally, the a there should be greater than 0. And of course, even not equal to 1. Okay, it shouldn't be, a should not be 1. A is not 1, but it has to be greater than 0. Okay, so what it means is that then the natural log of a is going to be a value, you know, so we can push that out as in this form. And that gets to divide each side. So if I isolate the ax dx, what it means that I'm just going to be dividing by a natural log of a of each side here. But because this side is going to give me a positive, I'm just going to represent it with some positive, some constants. So something like this. So this is always true. Those of you who will be doing Calc 2, you'll be dealing more of these stuff here. And so please take note of how they come about. They are not too hard. I want to believe that you just have to memorize them. You don't have to necessarily know how to derive them, but anytime you see them, you should be able to write them as such. Any questions?
I think we're good.
Okay, now let's look at the, I'm not sure what number this is going to be. Maybe you can tell me. I'm not sure if this is going to be rule 4 or rule 5. I'm not sure.
This would be number 4.
Okay, 4. Okay, so let's talk about the trig ratios. Okay, so indefinite integral of the trig functions or trig ratios. Okay. I'm going to start with, I think we considered this last time also, but let's start with ddx. If I have ddx of, well, let me start with the sine x. This is always going to give you cosine of x. All right. So what that means is that then if I take the integral of cosine of x dx, that should give me what? Sine of x plus c. This is always true. d dx of cosine of x, when you take the derivative of cosine of x, is going to give you negative sine of x. Okay, so basically what it means that when I take the integral of negative sine x dx, that should give me cosine of x plus, let's say, some c1, right? And the reason why anytime I do c1, what it means that then I'm going to be dividing through by something, so that will change at the end. Now you see that there's a minus here or a negative here, or basically it is -1. So I can put a -1 out and then finally divide both sides by -1. That will change our right-hand side. So if I do that, this the integral of the sine x dx will give me negative cosine of x. This could be a negative c1, but it's still going to be a constant, so I will just maintain my plus c. And this is always true. Are we good?
Yes.
Yep.
If we have tangent of x, what is tan of x? When you take the derivative of tangent of x, what do you have? Yes.
Secant squared x.
Say it again.
Secant squared x.
Secant squared x. Okay. Are we all good?
Yep.
Okay. So basically then what it means is that, oh, I think I'm exhausted the page here. The integral of that dx should give me tan x plus c. Are we good?
Yep.
So you can do all of these things yourselves because they are just reverse derivative and antiderivative. They are just reverse thing. I have exhausted the page. I have to go to the next page. If you would allow me to go to the next page, let's do that. Are we good?
Sounds good.
All right. Let's say this is the fourth one here. What if I gave you d dx of, let's say, sine 2x? What would be the derivative?
Two cosine 2x.
That's right. So basically, then what it means is that the integral of 2 cosine 2x dx is equal to sine 2x plus, let's say, c1, right? I have a 2 here. I can pull that 2 out, divide through by 2. And if I do that, it's going to give me cosine 2x dx should be equal to 1/2 sine 2x plus c. You know, I'm still going to be dividing this c1 by 2, but at the end of the day, it becomes a constant by itself. So I just do it that way. This is always true. Okay, so this is something that you have to know. It's not too hard. On the flip side, if I gave you d dx of cosine of 2x, basically, this one here is going to give you -2 sine 2x. And so we can also do the same thing here. What it means is that the integral of -2 sine 2x dx will give me cosine 2x plus some c1. Okay. And then what I'm going to do is I'm going to pull the -2 out and then finally divide by -2. So I will end up getting sine 2x dx will be equal to -1/2 cosine 2x, but I'm dividing up the C1 by also -1/2. I mean -2. But it will still be a constant at the end of the day, so I just maintain that. So this and many others that you want to do. I don't want to waste all the time on this, but this is how they all go by way of reverse stuff. When you go to Calc 2, those of you will be going to Calc 2, you'll be doing more of these ones. You'll be doing a lot of substitutions and all of that. So let me not waste the time on that. But this is stuff that you probably have to know how to do this. Example would be if I ask you to solve, let's say, 3x squared plus, let's say, sine x. So if they gave you something like that, you should be able to solve this easily. It shouldn't be too hard. I know I always say it, but they all come by way of practice. If you practice more, you would. So I can split this. Remember that back in the days we talked about when we're looking at the properties of derivative, there's still holes here. If you have addition or subtraction, you still can split it. That is one of the rules. I think I should have written that down too, but that is something simple to realize. So we can always split this up as this. So look at it carefully. We can always do this. It's one of the rules, actually. So long as you have addition and subtraction, you can always split them as such, okay? And then take your integral. So here I'm going to use the power rule. So that will be 3x 3 over 3. And the reason is that with the power rule, we add 1 to the power and then we divide by the result. And then when we come to sine, anytime we take the integral of sine, it is always negative cos. So this is going to give me negative cosine of x. And then I'm just going to attach my constant. And then this will end up being x cubed minus cosine of x plus c. And that will be done. Are we good?
Yes.
Yes, I had a question. Do the multiplication rules for derivative transfer also to integrals? Or is there a different method for that?
Yeah, it doesn't really do that. You have to use substitution.
Okay.
So you can apply, fine, you will see situations like that, but you have to apply the idea of substitution to do it.
Okay.
I would do a video on that. I just don't want to waste all the time here, but I will do another video on stuff like that, so that
sounds good.
for those of you who would be doing maybe Calc 2, at least you will be, when you watch this video, it will give you a clue when you get there. Okay.
Okay, thank you.
All right. And again, just like the quotient rule, when you see the quotient rule, now it's applied here under integral, but not as in derivatives. Here you also have to use substitution. You have to use substitution in all of these cases, and sometimes once you use substitution, sometimes you'll be getting something as in natural log forms and all of these. It's very interesting. This integral is very interesting, but as you go higher, you will see more of it. This is just the beginning. So, all right.
Okay.
All right. So let's look at what we call the initial value problem. Let me just quickly touch on it. Initial value problem. Initial value problem. This is the idea of you know, trying to get the C value. Okay, remember that the antiderivative belongs to a family of what functions that differ by what a particular constant. That is why we always add a C. I mean, you can add any constant that you want, K, whatever, P, whatever, so long as you name what that variable is for. But once we attach a C, it doesn't really give us the function that we want because we don't know what C is all about. And so this is a case where if we want to determine what that C value is, we need to be given some initial conditions that will help us to eliminate some other things, and then we can be able to find a C. Okay, this is the idea of what we call the initial value problems. So let me put it this way for you. So the problem, let's put it this way, the problem of finding a function, let's say y equal f of x, when we know the derivative and its value, let's say y naught at some point, say x naught is called the initial value problem. Is that okay?
Yes.
I think I have 5 more minutes. I think we can do this. Okay. So the idea here is we want to determine a particular function. Okay. Basically in the antiderivative, and then we add a C to it. We don't know what this C is. So until we are given these conditions, y naught and x naught, we can't find this C value. And of course, we cannot justify what the actual function that we're looking for is. Okay. Now I'm going to do some examples, but before we do that, let's take note of these ones. So note the antiderivative of f prime prime of x is f prime of x. Okay. Anytime you have a second derivative, its antiderivative is the first derivative. So in other words, f prime of x should be equal to what? This is always true. Okay. So take note of that. 2. Antiderivative of f prime of x is the actual function itself. So that means that f of x is equal to, so please take note of this all the time. 3. Remember we talked about rectilinear motion way back, right? Or what we call motion in a straight line. Here we're dealing with the position function, we're dealing with velocity, we're dealing with the acceleration, remember those things. So the antiderivative of the acceleration function, which mostly we do, remember that the rectilinear is always with respect to what time, okay? Which normally we do that. The antiderivative of the acceleration is the velocity, which normally we use v of t. So in other words, v of t is equal to the integral of a of t dt. Are we good?
Yes.
Yep.
The antiderivative of the velocity function, or the velocity v of t, is always the position function. And normally we use s of t for it. If you refer back to the note, you will see we were using some of these symbols here. So what it means is that then my s of t is nothing more than the integral of v of t dt. Okay, so these are stuff that you have to know under the initial value problem. I have 1 minute. I think I've tried enough, but I think my best is not enough. I want to do one example, but I can't do it because it's time. Unless, of course, you want to allow me to do it. Other than that, I will stop here and then continue with the video and then do another one, because sometimes when I prolong the video, you know, sometimes I have to resize it and I can't post it on Moodle. And so, pardon me, I'm going to stop here. I will continue with the video. I will do a couple of examples on this, and then I'll post it, and then I will do another one again. Is that okay?
Sounds
Okay,
good.
thank you.
All right. Let me pause it. All right. So basically, that is the idea of the initial value problems. We need to be given initial conditions. We plug those in there to eliminate a couple of things. Then we can find what our constant is. So let's do a couple of examples here. So question is given the graph of f of x passes through the point 9,3, and the slope of the tangent line at x comma f of x is 6x plus 2. Find f of x and f of 3. So this is the question. This is a purely initial value problem. we are given a couple of things. Given the graph of f of x, we don't know what that function is. What we know is that that function f of x passes through this point 9, 3, but the slope of this function, in other words, when we talk about the slope here, or the slope of the tangent line here, we're talking about the derivative of that given function. And so the derivative is given. We are to find the function that goes through the point 9, 3. So what we know here is that slope of tangent line, which basically is f prime of x, was given as 6x plus 2. We have this initial conditions. We have the point 9, 3, and what that means is that x is 9 and f of 9 is equal to 3. That is the main reason why it was written in that form. Okay, x f of x, that means x is 9, and then because x is 9, if we plug in the 9 here, it gives it what, or it makes it what, f of 9, and that should be equal to what, 3. Okay, so that will be our condition. Remember that the antiderivative of the first derivative is the initial function itself. So based on what we have written, we know that then f of x will be equal to the integral of f prime of x dx. Okay. So let's just start the page, but this is just going to be integral of 6x plus 2 dx. And we will need to take the derivative of that. I'm going to go to the next page. So f of x is equal to the integral of 6x plus 2. And just by way of the sum and difference, we can split this up as 6x dx plus 2 dx. You can always do this. From here, we use the power rule. It will be, there's a 1 here. So if I add 1 to it, it becomes a 2, and I divide by 2 plus. Now over here, you don't see any variable attached to the 2. It doesn't mean that there's no variable there. There is a variable there. That variable carries a power what? 0. So there's x to the power 0 there. So this is actually 2x to the 0. Okay, that is what it means, because x to the 0 there is 1. 1 times 2 is 2. And so if I'm going to integrate, then I need to add 1 to whatever the power here is. So this is just going to give me just 0 plus 1, if you will, and then 0 plus 1, and plus my constant. So that will be my f of x. And if I simplify, this is going to give me 3x squared plus 2x plus c. And that will be my f of x. So here I need to determine c. So this is where the initial conditions, what have you, will help us. So we know that, but f of 9 is equal to 3. This is what was given in the problem. F of 9 equals 3, right? And so if that is the case, I'm going to go up here and do my f of 9 f of 9 equal 3, 9 squared plus 2, 9 plus c. But again, f of 9 equal 3. So 3 will be here. That will give me 81 times 3, 243 plus 18 plus c. And I can easily find my c, which will be 3. That together will give me 261. And so my c will just be when I subtract this amount from 3. So that should give me negative 258. Therefore, function that I'm looking for would be 3x squared plus 2x minus 258 be your result. This is what we call the initial value problem. Then the question says that we should now find f of 3. So now f of 3 will be, I'm going to use here, so it will be 3 into 3 squared plus 2 into 3 minus 258. And this will be 9, 3, 9, 27. That will be 6, 258. And when I get all of these together, this is going to give me 33. 33 minus 258 will give me minus 220. 33, 258. So that'll be 225, negative 225. And that'll be your result. Let me do one more problem. This. So another example. Determine the position function as of t, given that its acceleration function a of t equal 24t squared minus 48t plus 2, given that s of 1 is equal to negative 9 and s of s prime of negative 2 equal negative 4. Stuff like that. Remember, this is under rectilinear motion. So we are given the acceleration a of t is 24t squared minus 48t plus 2. Remember that the antiderivative of the acceleration will give you velocity, and then the antiderivative of the velocity will give you what? The position. So we got to do two integrals here. Okay, So basically, I need to get my velocity function. V of t should be equal to the integral of a of t dt. So this is going to be integral of 24t squared minus 48t plus 2 dt. And I just need to take the derivative here. I mean the integral here. You do that individually or by individual terms here. So I'm going to use the power rule in this case. So this is going to be 24t cubed over 3. Remember, in all cases, you add 1 to the power and then divide by the resulting. So that will be minus 48t squared over 2. If the term is a constant, all that you do is when you're integrating, just add or multiply by what? The variable of integration. So 2 becomes 2t. Okay. Then plus your c. If you simplify, you're going to get 8t cubed minus 24t squared plus 2t plus c, and that will give you your velocity function. I think I wrote the problem wrongly. This one here is actually your v of t. This is the same thing. I mean, this one here is still v of t. This one here is still v of t, because when you take the derivative of the position function, it will give you velocity. Okay, so it's not a mistake, but I guess the way I'm doing the solution, you have to understand that this is still going to be equal to s prime of t. Okay, and so if that is the case, we understand the condition that was given there. S prime of -2 equal -4. So that means that my s prime of t is actually the 8t cubed minus 24t squared plus 2t plus c, and a condition was given as s prime of -2 equal -4. Okay, I think, yeah. So if that is the case, it means that anytime I plug in t, I mean -2 for any t, then my s prime of t becomes -4. So basically this is going to be what? -4 is equal to anywhere else that I put a ct, I put -2 there. Find my c. So -4 equal, this is going to be -8, so -64. That would be 4. So 4 times 24, 16, 18, 96. That'll give -4 plus c. What I can do is I can easily cross out the -4s out here. So this is basically going to be a 0, -64 minus 96 plus c. I can easily cross out. You can always do this, cross out this, cross out that, because they are the same on both sides. from there, I can find my C easily. That tells me that my C would be equal to 64 plus 96. And that will give me 160. Okay. So then what it means is that my V of t, which is the same as my S prime of t, gives me a very cool function here, which will be 8t cubed minus 24t squared plus 2t plus my C value, which is 160. So that is that. We are not done yet. So what that means is that then if I need to find my S of t will be the integral of S prime of t dt. And so, or basically it's the same as V of t dt, if you will. So this is going to be like that. 8t cubed minus 24t squared plus 2t plus 160 dt. Again, I'm going to do it straight. I'm not going to split them. You can always do that. So I'm going to do that, do the integral by individual terms. So this term here will be 8t4. Remember, we're adding 1 to the power and dividing by the result. So minus 24t cubed over 3 plus 2t squared over 2 plus, again, if it is a constant, just add the constant of integration to it, and then plus my C. So that will give me S of t and if I simplify, I'm going to get 2t4 minus 24 divided by that, 8t cubed plus t squared plus 160t plus my C. Okay, and then we also know the condition there. The condition was S of 1, but S of 1 is equal to -9. Okay, that tells me that then -9 will be equal to 2 of 1 to the 4 minus 8, 1 to the 3rd plus 1 to the 2nd plus 161 plus C. And we should be able to get answer from there. I have exhausted the page. Let me write this down so I can repeat it on the other side. 214.813 plus 1 squared 160 1 plus C. Go to the next page. Next page. So that will be -9 is equal to, so I'm just repeating what I wrote in the previous page, plus 1 squared plus 161 and then plus C. So in that case, I have -9, that will give me 2, that will give me 8 plus 1 plus 160 and then plus C. Okay, and I can simplify from here. That will give me -6 plus that will be -5. And so that will be positive 155 plus C and -9. So if I need my C, I just have to subtract that, something like that. And my result will be -160. So finally, I will have my function that I'm looking for, the position function S of t will be equal to t4 minus 8t cubed plus t squared plus 160t, and then my constant is -164, and that will give you your answer. Let me do one more and then I'll end this video. Let's see, 3. This question, I believe you will find a similar thing in your homework assignment. Says consider the function f of x whose derivative is f prime prime of x, and this is equal to 9x plus 6 sine x. And then it says that find f of x, given that f of 0 equal 4 and f prime of 0 also equal 4. And then it says find f of 3. So this is pretty much similar to our previous example on the velocity position thing here. So we're going to apply the same idea. Here we have the second derivative, f prime prime of x. The second derivative is just like you have an acceleration, basically. So that is 9x plus 6 sine x. We have these conditions that will help us to find our constants in all cases. Remember that the antiderivative of the second derivative is the first derivative. Okay, so what it means that f prime of x is the integral of f prime prime of x dx, and we see that the f prime prime dx is what is it, 9x plus 6 sine x dx. Okay, so basically what it means is that then we're gonna take the derivative, the antiderivative or the integral individually. This is going to give me 9x dx plus 6 sine x. That's going to give me 9x squared over 2 plus, remember that when we take the antiderivative of a sine, or basically the integral of a sine, gives you a negative cosine. So that will give me -6 cosine of x, and then I'll attach my c. So that will be my f prime of x. We are given initial conditions that f prime of 4, f prime of 0, sorry, equal 4. And so we can use that to find the c here. So basically what it means is that then 4 will be equal to 9 over 2, 0 squared plus negative 6 cos 0 plus c. So I believe you understand what we're doing here. This is the first derivative function that we got here. We want to find c. This initial condition is given to us. What it means that we have to, anytime we plug in x here, f prime of what? That value x gives us 4. So if I do that, I'm getting this. So that will be 4 here. This is going to go to 0. Cosine of 0 is 1. So that means that this is going to be negative 6 and plus my c. And so if I need to get my c, and c will just be 10. Okay, so that tells me that my first derivative is nothing more than 9 over 2 x squared minus 6 cosine of x plus 10. We haven't solved the problem yet. The question is asking us to find f of x. But what we understand is that the antiderivative of f prime is the function itself. So that means that then f of x will be equal to antiderivative of f prime of x dx. And this is nothing more than writing this. 6 cosine of x plus 10 dx. And we will just get the integral. I'm going to do it straight ahead. Just going to add 1 to the power and divide by the resulting power, which is 3. So basically this is what it is. Anytime we take the integral of cosine is sine. So that should give me negative 6 sine x. And then when we take the integral of a constant, we just attach the variable of integration. So that will be 10x. And then plus some c. If we simplify, we're going to have 3 crossing out that. So that'll be 3 over 2 x cubed minus 6 sine x plus 10x plus my c. A condition was given f of 0 equal 4. Okay, but there's a condition given. In other words, if I plug in 0 here for x, then the f of x becomes, f of 0 becomes what? 4. So basically this means that 4 will be equal to 3 over 2 0 cubed minus 6 sine 0 plus 10 0 plus c. That means that I have 4 here. Everything here will go to 0. Everything is sine 0 is 0. Everything here is going to go to 0. 10 times 0 is 0. So my c will be 4. And that means that then my function f of x will be nothing more than 3 over 2 x cubed, I believe, x cubed minus 6 sine x plus 10x and then plus 4 will be my function. This is what I'm looking for. And then finally it says we should find f of 3. So basically, if it is f of 3, we just plug in back here. 3 over 2, 3 cubed, minus 6 sine 3 plus 10 times 3 plus 4. Calculator, this is going to give you 27. 27 times 3, 60, 21, 81. So 81 over 2, 6 sine 3. I'm just going to do this in maybe 4 decimal places. See, sine 3. This is giving me 0.14112. That will be 30 plus 4. And so 81 divided by 2 will be 40.5. And then 6 times 0.14112 gives me 0.84672 plus 34. So basically, it will be 74.5 minus 0.84672 will give me this value here, which is 73.65328. That'll be your f of 3, and that will be it. All right, let me conclude here. That's the initial value problem.